before we start, I just wanted to understand the mix of the audience here. So how many developers here? Okay. How many people who are like project managers, program managers? Is there anybody? Okay. Any other architect kind of a role? Architect, people manager kind of a role? Fine. So predominantly developers, and we will talk about what are the aspects that come under the project manager, program manager kind of a role also. Okay, perfect. Release pipeline. Good. So, okay, I now work as a program manager, which is a servant leader role for 5 teams. And this is a perspective about first step to continuous deployment. So today's agile world is, most of the agile conferences talk about continuous deployment as a sort of a utopia. It's the ideal thing that anybody can do. You know, release cycles get slow, gets faster, and stress goes low. All these things are there, right? So does everybody understand the word continuous deployment? Or do you want me to shed a little light on that? If not, we can go ahead. Okay, continuous deployment is, I put a commit in, and the build becomes green, and then immediately it gets deployed to server. That is continuous deployment, right? So what are the, if you trace back from continuous deployment, what all is needed, right? Continuous deployment has a precursor step, which means the deployment is not automated, where you have a continuous delivery, which means at the push of a button, I can deploy, where there is still a manual control. So probably I will say, okay, after 2 weeks, every 2 weeks I will push that button, right? Where a manual element comes in. So continuous deployment, before continuous deployment, you get continuous delivery. And in order to do continuous delivery, you need something known as continuous integration, which means if there are 4, 5 teams or 10 teams or 100 teams working for a single product, they all have to integrate not before the delivery date, but regularly, right? That is continuous integration. So assuming that everybody understands continuous integration, the definition of continuous integration seems to be different for different people, right? So what according to you is continuous integration? How do you know whether I am doing continuous integration or not? I come to you one day and claim that, you know what, hey, I am doing continuous integration. But how will you know whether I am really doing it? Okay. Can you elaborate more on that?
If you get frequent releases, you know that.
Do I frequently release or not? That is one aspect that you can see. Anything else? Is there a need for integration in the first place? Are many features going on parallelly, or is everybody contributing to the same thing? Right? So am I in the need for integration, and is the master branch always stable or not? That is there.
In the tech side, we have a Jenkins job running, and we have a Git repository. Everybody is checking into the Git repository every day. We run a build, we run an automated unit test, and we look at the failure reports and all that.
Perfect. So you can also, one aspect of continuous integration is the tools that we use. Like he said, Jenkins could be there, right? And there is a different way of looking at it. We have to have all of these things in order to do continuous integration, right? But generally what happens when we go and talk to people initially, right, who claim to be doing continuous integration all the time, they say, I'm running Jenkins, so I'm doing continuous integration. Okay, provisioning a tool does not make you a practitioner of a practice. Jenkins is just a tool, right? Git is just a tool. But Jenkins, Git, release cycles, multiple branches or multiple teams committing, and then the master being stable, that is continuous integration. So what I wanted to stress upon is, having a Jenkins does not qualify you as a team that does continuous integration, but having the culture, practices, and results, that makes you continuous integration. That makes you a team that does continuous integration. Now, what are the aspects of continuous integration? What is CI? If running Jenkins alone is not CI, having a Git repository and then doing some automated test is not CI, what is CI in philosophy? So you break it, continuous and integration, 2 words are there. These 3 are mandatory for any team to be following CI, right? One is continuous, it is never ending. You will not come one day and say, hey, from today we will not integrate here. Let us do our work separately. Then it is not continuous integration. It is never ending. And it may be periodical. You might be integrating once in a day. You might be integrating every commit. Or you might be integrating once in a month, which is perfectly fine. But that is very bad. You know, if you integrate once in a month, you run into a lot of integration issues. And it is always a good practice to start with daily frequency, which is initially challenging, right? And you should be integrating, which means there should be a need for integration in the first place. If everybody works on, say, there is one team where I have one UI developer who works on only the UI code. There is one developer who works only on, say, backend code, right? And there is no point in running a CI server for that. You can just, have a single code base. If you have a single repository, 5 committers, then probably, it's not a very big CI system, but you just can, do the regular stuff, right? And it has to be tested also automatically. If it is not done, then it is not integration, right? Integration should not be like, okay, I'll integrate and then manually test it for 5 days. That should not be the case. And the last interesting part is that, yeah, please. It depends on what is required. If your aim is to do continuous deployment, then it should be production ready.
So that means the entire regression?
Yes, continuous deployment, it is production ready, right? And typically it is good to start with regression test cases. If you already have a lot of legacy code, then you might probably have to improve upon on a periodical basis. How much tests am I automating? It's not easy to start with 100% test coverage all the time.
It's not possible. Also,
yes, it's a journey. Start with CI and aim for CDEP.
Okay.
And stimulus response is the most important part. If it is not there, probably you are not doing CI. That is one very good indication. Stimulus response is sometimes a positive adrenaline rush. You see somewhere a build breaks red, right? And people run, people have to run, or anybody who is probably interested in the sanity of the application has to run, fix things and feel good about it. If this is not happening, build is breaking, people are sitting, relaxing, on the last day of the sprint they fix because someone else is coming and shouting, probably you're not doing CI, you're doing command and control, right? So that is something that we have to, think about. So you might just have these two things, and when you see this missing, it should be a part of the culture. You should see at least people running around, like, hey, I did one commit, that guy did another commit, both did not work well together. Now how do we fix it? People have to collaborate to fix builds, right? So what do you see in this phase? Has everybody seen this phase at least once in their lifetime? They must have, right? If people are doing CI, have you fixed a red build? Or have you seen some other people fixing a red build? What happens at that time? What happens at that time? What are the things that people generally say? Build is red. What happens after that? Fix it, fine. Who tells to whom?
Revert back the code and then...
people just sometimes say revert back the code also, right? Again, who tells to whom?
Release manager.
Okay, team within themselves would say to each other, okay? Or should it be like, let's fix, right? Anything else that happens? Imagine you have 4-5 teams, right?
There is a release management team.
Sorry?
The release management team. They will come back and then they will say.
Okay, release management team is the only one who will know that build has broken, and they'll come back and say what?
Immediately the team groups, join to see what needs to be fixed and what broke.
Okay.
And immediately we'll get into the action and to fix it.
So the automated system sends you an email based on who actually checked in last,
yes.
and it sends you an email, right?
Mail to the person and the Scrum Master. So immediately the Scrum Master will call either the person or the group, depends on what is the severity of the issue. And we'll get into the immediate, we'll discuss about the immediate resolution and code it to fix the issues and make it green.
Okay. And how are the emotions running at this point of time? If you are talking about build has just broken.
Initially it was very difficult to accept, but then...
Very difficult to accept. There is some sort of denial.
Yes. Then when we practiced it for more than 3 to 4 years, it became, yeah, I did it and I can fix it as well.
Yes. Yeah. So they would say, blame game is a very interesting aspect that comes only during negative situations. Most probably positive situations will have the opposite of it, where all things went well because I did it, right? And when things don't go well, probably it did not go well because he did it. That is how things go, right? There is a term in social psychology for this. It is called, what do you call that? I don't remember the name, probably. I'll remember and get back to you on this, right? So what happens during the stimulus response cycle is that blame game, mostly, right? So it can be either of these variations depending on how your organization structure is. First thing could be, Raj broke the build. What a careless guy, yaar. Okay. And then, why should I fix it? It's Raj who broke the build. Right? Two teams, integration scenario, right? And then there are different kind of people altogether. Third kind is my favorite. Dear boss, I'm blocked until Raj fixes the bill. Why should I suffer for someone else's mistakes? Sincerely, the escalator. Right? These are one gang of people. They still exist. Do you see these people there? Everybody will be there. Everybody will be seeing such people, right? And there is another gang of people who are over-empathetic. Poor soul Raj, he just needs some more training, right? And the last one is, Raj, you're a good developer, but you could have done better at avoiding some build failures this year. What is this? Appraisal cycle. When your build failures reach your appraisal cycle, that is what is called a career nightmare. So these are common, right? These things happen, right? So how does this adversely affect? Is there any Raj in this gang? No, right? Okay, good for us. All of us did not, nobody broke the bill here. But still, assume that there is a Raj. And how does this particular mindset of blaming the committer or blaming the bill breaker adversely affect that person and the organization? Any thoughts? Raj is waiting for his chance. Okay, let me see who breaks the bill next. Okay, so it's a positive effect, right? Okay, fine. Now I broke the build. Probably next time I should be very careful. I should probably be, making whatever it is necessary to make sure that the build does not break there. Okay, let's see some of the adverse effects, whether we have covered them or not. This is my list. See, this is Raj. Does he look miserable? He does, right? So what happens to the following in this condition? What about commit frequency? How frequently will Raj commit? He'll be afraid to commit, right? So probably he'll be committing, I don't know, depending on how frequently his boss goes on a holiday, right? And then what will be the size of each commit? Small, big. If you commit, it will be big because he commits less frequently, right? So he will probably, develop a full feature or full story and commit it to trunk on one day where he had like 70, 75 files changed, right? It's a very big commit. And what happens when the commit is big? Is it good to have big commits? Why? More risk, fine. More productivity also, right? Big commits. Okay. One distinct aspect is that bigger commits are harder to debug. Assuming that things are failing in the normal state of affairs, if a big commit goes in and it fails, it's very difficult to narrow down the cause of why it was failing. It's a little difficult than smaller commits, right? And what is his ability to take risks? As he was rightly pointing out, the ability to take risks will go down significantly because he's always on the defensive, right? And what is his willingness to face uncertainty? Like, he will not be able to face any uncertainty. He will go back to the product manager and say, boss, probably I was doing the coding in the last day because you came and changed the requirement. You should not change the requirement hereafter. So it will go back, right? It has a, domino effect. And what happens to the bug count? How? Commit is big, okay. After that? Not tested for a long time because he is doing less frequent commits. Which means that at the end, it has to be tested, right? There could be the other case also, where just to make sure that his unit tests are not breaking the build, I have seen people commenting unit test cases and checking it. Okay, the explanation for that commit will be, test cases are failing, and I'm commenting those. That is the explanation that people offer. And sadly, it is a widely accepted strategy for project managers. From personal experience, that's an accepted strategy if you're near the time, right? And what about the general motivation of the team? Let's say Raj's teams have 5 developers and this guy is one of the developers. What happens to the motivation of the team as a collection? Team commits lesser, right? Because they always anticipate bad things to happen, so they will commit lesser. Motivation goes down, right? And anything else, these are the things that we know about. And there are 100,000 things that we don't even know about. Because Raj might be from a different family background, because of which he might have some personality traits. Right? We don't even know about all these things. We are talking about the average normal developer who does not have any problem in life, can have these many problems just because he is blamed because of a red build. Right? So this is a problem. And what happens to the organization as such if we have a lot of Rajs in our organization? What happens to the organization as such? Yeah, these things collectively add. So the right approach should be find out all the Rajs, whoever breaks the bill should be fired, right? No? Is that the approach? No. So let's start thinking about, as she rightly said, does Raj really have full control on whether his commit is going to break the build or not? Is it yes? Is it no? Okay. Let me remove the word full. Now yes, no. Or something in between. Maybe. Right? So if I maybe have control on some things, it's so inappropriate and it's so offensive for somebody to blame me for it. Right? It's so inappropriate. And the bad things happen when I start internalizing it. I was stupid, that is why I broke this build. Even if it is not your problem. Many developers go to that stage, right? They think that, okay, fine, I'm breaking builds left, right, center, probably there is a problem with me. I've had one developer come and cry in front of me, which is a very sad state of affairs. It's not a big problem, right? So, now let us question the popular belief. One popular belief is that build has to be green all the time, right? But the reality happens to be that build does not have to be green all the time, right? Contrary to the popular belief, the build or the build pipeline does not have to be green all the time. However, the intention and action to keep it green should be there, which means it's okay to fail a build, but fix it as soon as it fails. It's okay to fail the build. Now, when you take that kind of a stand, that kind of a position, what happens? What thing goes away? It's okay to fail a build. Blame goes away. Blame goes away. So all the negative effects sort of get sidelined. It's very difficult to internalize this culture, but yes, assuming that we have internalized this, then blame goes away. So all the negative effects of the blame go away, and people start feeling positive. And what does this give you? It empowers you to fix any failing build, irrespective of whether you committed or someone else committed. Right? It gets things done, right? Let us have a different approach of understanding whether Raj really has full control of whether his build fails or not, okay? I think of my code commits as cars that I travel into a road. Like this is the common branch that, this has to be green all the time, okay? And this is the already existing code that is coming. This is a big truck C, and my car is a very small, and this is the intersection. And this is my point of commit. And I see a big wall here. So from the car, I cannot see the road. That person cannot see my car, right? This is how the commit goes, right? If you see your Git branch or whichever branch you are committing to, at the moment of pressing or typing the git push command, you will not have visibility on things that are already there in the upstream, right? So to identify things here, this is your commit. This is your teammate's pending commit, which probably he is the next Raj in the line. And this is the sum commit, which has been done after your last pull. You pulled, you did some code, and you are committing. So between that, somebody committed. That is that commit, right? One challenge is, can you be 100% sure about driving into the main road without an accident here? No? Yes? So that brings us to the next question. If there is a way, what would you do in this situation? These are very common, right? You see these kind of roads everywhere, right? You see visibility blocked at multiple places, right? But still people manage to drive cars, right? Some kind of a group decision should emerge. You understand what the point I'm trying to make, right? It's not impossible to control. I can be sure, provided something else happens. I cannot go and break the wall just because I have to drive inside this thing, right? So wall is still there, right? But what I can do is, that brings us to the next question of what I should do in order to not hit another vehicle. What you will do? You're driving a car, you see an intersection, what do you do? Natural reaction would be to slow down. So you have to slow down to the point where you're not moving, get out of the vehicle, and then see that side and then go. Translating to Git repository standards, you have to basically pull every time you want to push, and then integrate, run tests, and then push. It sounds so easy in theory. Everybody cheats in this aspect. Everybody, no developer has been prone to this aspect. Everybody cheats. You can rebase one time. You can rebase 2 times. Tomorrow is the release date. Everybody is going to commit. Let's say 50 people use the same trunk. It is practically impossible for you to integrate with each commit before pushing. Because by the time you're integrating and testing, another commit would have come in. Right? So you have to slow down to the point of immobility. Even when I slow down this car and get into the lane, what I do, this is an intersection, I go check no cars are coming, then I come back. But what if a Ferrari comes by the time I try to drive? Right? A faster vehicle can come. So what I should do? I basically have, if I have to move fast or if I have to move at all, right, I have no control on whether my commit is going to break or not. Do you agree with me this? Now, is it okay to blame Raj for this? Not at all, right? It's an injustice. See, it's all about, how the organization is structured and how people try to respond to 2 different things. People have internalized the belief that when there is red, something is wrong, and our instinct is to find out not what is wrong and what can be done. The first instinct is to find out who did this. Right? So that is something that needs to be changed. That's the whole point. But is there a problem in this theory? There is a big hole in this theory, right? I am sure somebody, probably they're not voicing out, they might be just thinking that this is a ridiculous piece of joke. What if my car could not run properly even before the merge? Unit test, I forgot to add a semicolon at the end of the line, committed. This is happening, right? These also have a fair percentage of why the compilation fails here. Compilation fails, maybe not because of a class dependency. It might be because of a place where people somehow forgot to change variable in one class, and another class they change the variable name. So there is a method name change. Semicolon, it's very common mistake, people forget semicolons, particularly when you have Java language. And people do other kind of things which are, you cannot say that these are unavoidable, right? When we take a stand that Raj should not be blamed and the build failure is unavoidable, you're basically ignoring this possibility, right? Now, Raj will not be blamed here also. Because, before answering that, why Raj should not be blamed, let's talk about 2 kinds of failures that can happen. One is avoidable failure, another one is unavoidable failure. Avoidable failure is a missing semicolon. Okay. Unavoidable failure is an integration issue where someone else offends my commit, and just because he got to commit first, he is able to stay blame free. Just because I had to commit second, I take all the blame. Right? So if you classify these 2 build failures as avoidable and unavoidable, then you get a new mental framework in which how you can deal with them. So what if a developer creates an unavoidable failure? What if Raj misses a semicolon and commits? Right? What you can do? Find ways to help it to avoid it. So naive, right? And it looks like a bad step, or because nobody knows how exactly to do that, and we do not know how effective it is, all these things, right? It looks like a generic solution that you will fill in a quiz program. How do you help Raj? Okay, tell him that he should find ways to help the developer to avoid it. But as an organization, you can find ways where Best case is to automate the avoidable failure check before commit. If you're using like current version control systems, everything comes with sort of a pre-commit hook, right? Use them wisely. Anything you classify as avoidable should be checked in pre-commit hook. And luckily, statistics say most of the time, at least from the statistics which I gathered in the past build failures, 8 out of 10 issues turned out to be anything that can be checked within like 5-10 minutes, 5 minutes, let's say. So if a developer can wait for 5 minutes before committing, which is good, which is stopping a lot of problems at the other end, you can do it in pre-commit hooks, right? So if you have not started looking at pre-commit hooks, this is the time that you should start looking at them. That is the right place where you have to fix the avoidable. But then, if you are not able to do some things like that, worst case could be that you police a checklist for the commit and ask someone else to vouch for him, which is a bad idea, but still a viable idea. So these are the two ends of the spectrum. How to avoid avoidable failures is to use pre-commit hooks or force a checklist. That way, avoidable failures will not get into your master. Clear, right? Am I making sense, or probably, am I making sense? Yeah? Okay. Now, remember one more thing. Developers don't intentionally cause havoc, okay? They are calm human beings, unless you steal their coffee mug. Okay, that is their temperament. So they don't intentionally break things. That's not on their agenda. Nobody comes to a company with an agenda that I have to break 5 builds today. Nobody comes with that agenda, right? So if it is unavoidable, then probably they are doing it because the organization allows them to do it. So we as an organization should start looking at, or organization may be a big word, probably a team, because each team's things can be different, right? So team has to look at what are the pre-commit hooks that it has to maintain and police. Now, what after unavoidable failure? We talked about avoidable failure, what should we do? But unavoidable failure has happened. What should we do after that? So all hell breaks loose, right? Unavoidable failure happens. After that, what happens? Unavoidable failure is a reason for celebration. Remember this always. Which means that you have uncovered an integration issue, right? It's a reason for celebration. So all hell should not break loose. Celebrate and fix it immediately, right? You get this point, right? If this build had not broken today, it would have broken in customers in some other time, right? So always make sure unavoidable failures are celebrated. That is how people will have the culture of what? Not thinking twice about committing a code here. Like, they should be able to commit code faster. They should be able to move faster without the fear of failure. So avoidable, change the system. Unavoidable, celebrate. That's the thing. So how can you basically, change this culture at a developer level? What if a person commits and then goes on a leave the next day? If he's the only person who can fix that build, then that becomes a problem, right? So what you can do is, instead of punishing the build breaker, appreciate the person who fixed the build. Start acknowledging, oh, hey, a build was broken and this person fixed it. Even if the same person's commit broke the build, even. That is very important, right? So more people get appreciation towards fixing builds, people will go into action mode rather than blame mode. We want builds to be fixed. So start appreciating, probably create a weekly list of people who fixed the builds this time. Share it probably during your sprint review, sprint retrospective, share it with your management, whatever it is, right? These things can be done. And if you're a developer, you can talk to your Scrum Master, or you can talk to your manager about all these things. Because these are positive things that make your workplace happy to be in, right? So don't create a culture of blame, create a culture of action. That is what is important in today's life. So appreciate the people who fix the build, and don't blame the people who fail the build. That works a lot, right? And this also motivates people to fix immediately, because it creates a competition. Who will get the name there, right? Will my build fix go first or his build fix go first? It creates a positive competition among people also. That makes people that makes sure that, okay, fine, build will get fixed now or in a shorter time. So these are some psychological tweaks that you can do to your developers so that they can get motivated and not feel manipulated about doing things. Right? You're not manipulating the developer here, you're actually driving him towards action. That is what is important. And now, everybody wants to track something. If at all we change this mindset, let's say we are adopting blameless CI from today. But after that, what do you want to track in order to make sure that you are actually making sense, or you are just doing something and not having results out of it, right? So if at all you want to track in this kind of system, blameless CI system, what you can track is, what not to track is who broke the build, right? And never ever track how many times the same person broke the build, because appraisals may matter. So don't ever track them. But care very deeply about two things: total build rate time. It might be on a daily average type. If you are using Jenkins, Jenkins gives a nice plugin which gives you this kind of a graph. Blue means successful build, red means failed build. So this team has a lot of failed builds, right? So total build rate time on a consolidated level, not on a commit level. So as a team, we had a single master or whatever branch we had, and this master was unusable for so much of time in a single day gap, and start displaying it very easily to all the people, which means you can set an increment goal, okay, which is the reaction time. Typically, you are measuring the reaction time by displaying this metric. Build rate time goes down, which means the reaction time has gone up. Get the point? You want me to repeat this point? Total build rate time goes down, which means that people are fixing builds proactively, right? That is something that you can measure to check whether people are actually fixing builds or not, rather than believing that, okay, everything is fine. This will give you an indication whether there is a culture shift or not, this number. Second number of unavoidable failures in a particular iteration or something. If it turns out to be 0, if you had 0 unavoidable failures, all are avoidable failures, then what's the point? You don't even need integration in the first place, right? No integration issues, right? So if it is a continuing trend, not for one iteration, probably if it continues, 0 unavoidable issues for 5-6 iterations, either you're classifying everything as avoidable because of management pressure, that could be a situation, or it could be even that you don't even need integration in the first place, because I have seen teams where, this folder is mine, this is my territory, don't come inside, this folder is mine. People create territories in code base. That is a possibility. If that is the total case where they do not have to work together, then there is no point in setting the system up at all. This validates the validity of your system. And this also creates a trend. If the number of unavoidable failures go down or go up, it creates an indirect reference to how clumsy your application design is. If it is totally entangled, number of unavoidable failures will be going up. So you can have a word with your architecture team and ask them, hey, see, this is happening. Can you probably measure the, what do we call that? Sonar gives a very nice metric for that, entangledness. Okay, how entangled is our application? Then probably you could decouple something so that they can get better, right? It gives you indirect feedback about how entangled your code is. That is very important feedback that is not very easily appreciated in the first place, but it is very useful. How are we doing on the time? 15 minutes more. I think we are good then. And also, this is the number of unavoidable failures is what you can showcase to other people as to the effectiveness of your CI systems. These are the possible customer bugs which got fixed even before we started getting into the testing cycle. This is the effectiveness of your CI system. This proves the ROI of your CI system directly if you want to talk to any person who is the money grantor for your projects. They will be happy to see these kind of fields. Only these two metrics, nothing else. What does the first metric tell us? Total build rate time. What does it tell us? What is the turnaround time? Are people really fixing builds or nothing is happening because of this mindset change? It's a validation for your theory, right? And number of unavoidable failures, what does it do? Gives a sense of code quality or the dependency hierarchies. Anything else? Blind spots. And it also checks, puts an acid test to whether you even need the continuous integration in the first place or not, right? If you measure these two things and probably change the mindset, of people who work, because you're changing the mindset and the total work experience of people who are in the lower levels of hierarchy, and they do not have a lot of conventional power. Because when you get into a meeting room setting, or when you get into a group setting, there is a theory, okay, it's like, the voice of the person with the highest salary wins, right? So developers are sort of the theories, traditional theories that we have, like punish the build breaker. There are applications. Okay, Jenkins has a build monitor, which gives you a list. How many people have seen that? There is a build monitor. It gives you what is the name that they use for the people who break the build. Culprits. Okay, so they call the people who committed as culprits, right? That is a very offensive language to use on top of a developer. Nobody is going to stand that language. They might laugh, they might say that it is a learning, but internally nobody is going to accept that language if it is not in their control. And the other thing that is happening is they think that they are culprits because they are new to the industry, and they start thinking that they spread the same philosophy over to other people. When someone else breaks the build, they will go and say, hey, you broke the build, right? So they don't start getting into the nitty-gritties of whether I do really have control or not. So you change these things, and probably people will start earning for more action rather than more blame. That is the whole point of this idea. And this is pretty much all I have, right? And this basically creates an atmosphere free of blame and full of trust, and it improves the transparency as well, right? In terms of what we can do and what we cannot do. Thank you very much. You have been a wonderful audience. Thank you very much.